So the product is called Prima. It's a little chip that's inserted in the back of the eye. It's an hour outpatient procedure. Just you insert it to the front of the eye, you leave it under the retina, and the chip has all these little hex grids. And each one of these hex grids is a little solar cell, basically. So the patient wears glasses that have a laser projector and a camera. The camera is looking out at the world. It converts it, it simplifies it, converts it to an infrared image, and then it uses the laser projector to project this infrared image onto the implant. And wherever the implant absorbs infrared light, it stimulates. And so this is actually a really elegant idea because that's the whole implant. There's no wires, there's no battery, there's no cable coming out of the eye. It's you send it energy and information simultaneously in the laser projection. The original inventor of this technology is a professor at Stanford, Daniel Planker, and the electrical engineering department. And we're fortunate to be able to own and commercialize that idea now. The current device has 100 micron pixels. So it stimulates that first layer of cells in the eye, the bipolar cells. And each pixel simulates a bunch of bipolar cells. So the next step is to shrink those to make it smaller and smaller until you get towards native acuity, like the native resolution of the eye, which we think we can get to in a couple device generations. Right now, it's just black and white because when you stimulate all of these cells, you average their representations together, and one of the things you lose in that is color. There's no such thing as a white photon.
Okay.
If you look on the color spectrum, there's no white. White is when your brain loses spatial temporal resolution to distinguish what colors the photons actually were. And so when you stimulate a bunch of bipolar cells, this averages them together and you lose the color resolution, so it shows up as white or black. But we think that in the next device generation, we might be able to get red and green. Blue is a little bit trickier, but there's a path there.